Everyone. Welcome to Chemazon-Complete Chemistry. So in today's video, we are going to learn about the introduction of pericyclic reactions, what are the different types of pericyclic reactions, and we will also see some of the examples. So this is going to be just a brief or short overview of what is pericyclic reaction. In the further videos, we will learn about each reaction in much more detail. Okay, so coming on to what exactly is pericyclic reactions. So we all know about what is a polar reaction. Okay, there is a electron rich species, that is a nucleophile, that attacks the alkyl halide and we get the product, that is a nucleophilic substitution reaction. So here basically there are formation of the charges or charged species. Okay, the other type of reaction we know is a radical reaction. What happens in a polar reaction? This is called as a heterolytic cleavage. Okay, that is there is separation of charges. One of them gets the negative charge, that is Br minus, and another one gets the positive charge. There is separation of charges or pole formation. That is why it's called polar reaction. What happens in a radical reaction? There is homolytic cleavage. Homolytic means a bond will break and both the atoms forming the bond will get one electron each. Okay, and what basically happens in a pericyclic reaction? So in polar reaction, we know there are a lot of reagents that are involved. Okay, whereas in pericyclic reaction, it is not affected by catalyst, it is not affected by any reagent. The only thing that determines the product of the pericyclic reaction is it is basically the heat or light. Okay, only these two things are required, either heat or light condition. Okay, either temperature or heating or light. That is, it is called either thermal reaction if heat is involved, and it is called photochemical reaction if light is involved. Okay, so pericyclic reaction is the one in which there is electrons in the reactant are reorganized in a cyclic manner. That means there is only rearrangement of electrons. Okay, only electrons are moving. Okay, and either pi bond will break or new sigma bond will be formed. Okay, and what is formed during the course of reaction, pericyclic reaction? There is only one cyclic transition state that is formed. Okay, and what are the types of pericyclic reactions? So they are broadly classified into three types. One is the electrocyclic reaction, another is called as a cycloaddition reaction, and the third one is sigmatropic reaction. Okay, so why the name pericyclic? Peri means periphery. Okay, and cyclic means the electrons move in a cyclic manner. Okay, so electrons moving in a cyclic manner around the periphery, or you can say border of the reactant. Okay, that is why it is called pericyclic. Okay, and what are the key or important features? All these three types of pericyclic reaction, they are concerted reaction. Concerted means they happen in one single step. Okay, and just now I told you that there is one cyclic transition state that is involved. Okay, and what is transition state? It is a state during the course of reaction where bond breaking and bond forming take place simultaneously. Simultaneously means both bond breaking and bond formation will take place at same time. Okay, there is no intermediates that are formed. Okay, what is the other important feature? It is stereoselective. Okay, highly stereoselective, and the stereochemistry of the product, it depends on two things. One is the number of pi bonds that are involved in the reactant. Second, the reaction condition, whether it is thermal or photochemical, that is either whether heat is involved or light is involved. Okay, the stereochemistry depends on that. And the third one is it is not affected by change by catalyst or change in solvent. So coming on to the first reaction, that is called electrocyclic. Okay, as the name suggests, electro means electron and cyclic means the electrons of the different pi system. Okay, the pi bond electrons will move in a cyclic manner, and what will happen is a new sigma bond will form between the end of the pi bond. Okay, whatever the pi bonds are in conjugation, at the end of that conjugation one new sigma bond is formed. Okay, and the product, what will be present in the product? One extra ring is formed and the pi bond is less. Okay, now let us understand with the help of an example. Now the electrocyclic reactions are of two types. One is called as the electrocyclic ring closure reaction. Okay, why it is called a ring closure? So you can see the reactant, it is open chain system or aliphatic system. Okay, it is open chain, and the product you can see it is a closed ring. Okay, that is why it is called electrocyclic ring closure reaction. So you can see 3 pi bonds are in conjugation. They will move in a cyclic manner. That is why it is called electrocyclic. Okay, the electrons of the pi bonds are moving in a cyclic manner. And this is the two terminals of the pi bond. You can see here a new double bond, new sigma or new single bond is formed. Okay, and one more feature is the product has one less pi bond. So in the reactant you can see there are 3 pi bond, product there is only 2 pi bond, that is 1 pi bond is less. Okay, so two important feature of electrocyclic reaction: one, new sigma bond is formed; second, the number of pi bond in the product is one less than that of the reactant. Okay, so electrocyclic reaction, basically they are reversible reaction. So ring opening reaction can also take place. Now there will be opposite thing that will be happening. Sigma bond is breaking and you get the open chain product. Okay, and here again it will be having one extra pi bond because it is reverse. Okay, the second type of reaction, that is cycloaddition reaction. Okay, now how do you differentiate or how do you identify electrocyclic reaction? You can see here there is only one reactant that is involved, whereas in cycloaddition reaction there will be always two species that will be reacting. That means there will be two reactants that will be reacting. Okay, so this is an example of a Diels-Alder reaction. Okay, one compound that has two pi bond, this is called as a diene. Ene means double bond, di means there are two. Okay, there are two pi bonds, that is why this is called as diene, and the one having only one pi bond, this is called as a dienophile. Okay, so the diene and the dienophile, again there is movement of only pi electrons. And what are the key features here? There are two new sigma bond that are formed. Okay, and there is rearrangement of the pi bonds, and there is one new pi bond that is formed. Okay, so what is happening here? The product has two fewer pi bond than the sum of the reactant. Okay, two pi bonds are less. In electrocyclic reaction only one pi bond was less. In cycloaddition there are two pi bonds that are less. Here you can see 1, 2 and 3. 3 pi bonds are present in reactant. In product you can see there is only one pi bond, that means two are less. Okay, so this is one type of this is the example of cycloaddition. Why it is called addition? Because two different reactants are adding, and cyclo because it is a cyclic ring or cyclohexene that is forming. Okay, the third one reaction, that is called as a sigmatropic rearrangement. How do you identify this? Sigma means sigma bond or single bond. Okay, a single bond will be broken in the sigmatropic rearrangement. Again here you can see there is only one reactant that is involved, and which sigma bond is broken in the middle of the system. Okay, so here you can see conjugation is broken. In electrocyclic reaction, if you see, there was continuous conjugation that was present, but here there are two pi bond, in between that there is one sigma bond. Okay, this sigma bond will break, the electron will rearrange, and you will get the product. And in product you can see one new sigma bond is formed. Okay, so what is a key feature here? Product and reactant have same number of pi bond. In electrocyclic there was one pi bond that was less. In cycloaddition two pi bonds were less, and sigmatropic there is no change in the number of pi bonds. So in this way you can identify whether a reaction is electrocyclic, cycloaddition or sigmatropic. Sigmatropic, here you can see reactant there are two pi bond, product also there are two pi bond. Okay, the only the position of the pi bond is changed. Okay, here there are two pi bonds here that have rearranged, and the two sigma bonds have become two pi bonds. Position of the pi bonds have changed, number is the same. Okay, and there is one more type of sigmatropic rearrangement where the terminal sigma bond is broken. Okay, this is called as a ene reaction. Okay, here also again the reactant has two pi bond, product also has two pi bond. Okay, a new sigma bond is formed, but the number of pi bond is still the same. Okay, so I hope you have understood all the types of three types of pericyclic reaction. So we'll end this. In the coming videos we will see each reaction in much more detail. What about the stereochemistry of each reaction? How do you decide the stereochemistry? And how do you approach using the molecular orbital theory approach? Okay, thank you.